This is section 1.2, summary statistics. And today's learning objectives are to define and calculate the sample mean and to define and calculate the sample variance, and also standard deviation. Let's start for some basic definitions of the statistical tools that we are going to be dealing during this course. First of all, we have the population and the sample. So the population is the big set that we want to analyze, and there are some properties that we want to know. And the sample is a subset of those populations. Let's say, for example, the population is the number of students of the university, and we want to measure the height of the students. One way to go is to measure the height of every single one and take the mean, the variance, the standard deviation, and the population size. So we are going to call those the properties of the population. So mean is denoted by mu, variance is denoted by sigma square, standard deviation is denoted by sigma, is the square root of the variance, and the population size is denoted by uppercase N. So you can see that these are Greek letters. And on the other hand, we have the sample. Well, sometimes it's very inconvenient to deal with the whole population, and sometimes the whole population is really hard to analyze. So one thing that we can do is to take a sample. Well, sample is just a subset of the population that we take and look. So this is the sample, and the sample contains some elements, and we want to do the same thing: the mean, the variance, the standard deviation, and with those results we want to infer what are the properties on the population. So in the sample case, those are called statistics, and we are going to infer the properties of the population by computing the statistics. Okay, so we have the mean, which is denoted by x bar. We have the variance, which is denoted by s. Standard deviation is the square root, variance is the square root, and standard deviation is the square root of the variance, which is s, and the size of the sample is n. So this is the size of the sample. Okay, now let's have a look to the definitions of mean and variance. So first of all, I'm going to have a sample. So sample is a subset of the population. We can define it in terms of a vector. I call it vector x, and as such it has some elements x1, x2 until xn. So we have n elements. I make an example over this line. So if those are real numbers, we can actually order in ascending. So x1, x2, x3, x4, and x5. And the mean, the definition of the mean, is the sum of all of them divided by the number of elements. So in this case, x1 plus x2 plus x3 plus x4 plus x5 divided by 5. So that will give us a value that we call the mean or the average. So in this case, it's going to be located in this point, and this is an assumption that I'm making. So this is the mean of the sample. Now,